Welcome to today's tutorial from the TwinSAFE department. Today we are talking about AX8000 projects with the use of the primary and the secondary feedback. My name is Martin Früchtel from the Product Management Safety. After some basic information about today's tutorial and the description of our demo system, we show you in TwinCAD 3 how you can configure your project for primary and secondary feedback. And then we finish today with an outlook to the next tutorial. The goal of today's tutorial is the creation of a TwinSAFE motion project, and with that TwinSAFE motion project, we create safety functionality using the primary and the secondary feedback. As prerequisites, you need a TwinCAD 3 version greater or equal to 4024.11. You need a TE9000 version greater or equal to 1211. You need a TwinSAFE firmware on the AX8000 greater or equal to 03. And finally, you need an AX8000 firmware greater or equal to 0104 with the default module ID active. The start of today's tutorial is a TwinCAD 3 solution with a standard PLC project and an EL6910 project. For our hardware, we are using an CX for the EtherCAT communication and the standard PLC. We need an EL6910 as master TwinSAFE logic, which is talking to the AX8000 and also talking to an EL1918 with the connected light barrier. The AX8000 in our system is an X2XX, a safe motion version, and we have two feedbacks today. We have the primary feedback via OCT safety. In our case, it's an AM8021 motor, and we have a secondary feedback connected to the front of the AX8000 via NDAT 2.2 safety, which is mounted on a linear axis. The required safety functionality today is we want to use the OCT safety, the primary feedback for a safe speed functionality, and we want to use the secondary feedback for the safe position on the linear axis. So now it's already time to start our live demonstration. We have our TwinCAD 3 solution with the I/O configuration and a standard PLC. And we are starting our tutorial by creating the safety project. So we start our TwinSAFE motion wizard. We choose our AX8000. In the next step for today, we are using channel B. So we configure channel A to be single turn because we don't need it. And for channel B, we use multi-turn because if you choose multi-turn, you can also select the SLP, the safe limited position functionality. Within the function overview, we are choosing SLP and SLS for channel B today. Then we have to rename our TwinSAFE motion project. We map the EL6910 project, so we don't have to create the connection on our own. We check the safe addresses and let the wizard do its work. After the creation of the TwinSAFE motion project, we start by linking our error egg and our run signal to the PLC. And we also go over to the EL6910 to do the connections in our prepared safety project. We have a global enable signal in our tutorial today, so we are mapping it to the STO and SS1 signals. We map the acknowledgement request signals for channel A and channel B. And we also connect our error eggs to the two channels. So now we start with the SLS with the safe limited speed functionality, because in this case we are using the primary feedback, which is also already configured by the TwinSAFE motion wizard. So the only step we have to do here is we go to the SLS TwinSAFE group and input our pre-calculated parameters. So basically we are already done with our safe limited speed functionality. and we can go over to the safe limited position and the secondary feedback configuration. In order to use the secondary feedback, we have to go over to the drive manager first to tell the drive managers that we have a secondary feedback. On the starting page, we can already select the configuration of the secondary feedback. So we choose as function linear function on the left, and we select our Heidenhain encoder, and in the marked line we see it's a single turn resolution encoder with a 36-bit resolution. We let the drive manager do its work, and we choose easy parameterization. So the drive manager configuration is done. Now we have to go to the safety project, to the configuration of our target system of the AX8000. We have to go to the object C3B0 and enable the secondary feedback. It's a 36-bit encoder, so we have to configure also our encoder position shift. So we have a 32 aligned value, 32-bit aligned value. So we need a shift of 4 in our case. And last but not least, we need the parameter CRC for the secondary feedback. In order to get that, we have to go to the AX8000 in the IO configuration, to the COE objects. And there also we have to go to the C4C2 object where we see all our encoder parameters. Last object is our parameter CRC, in our case hexadecimal F8AA. So we remember that. We go back to the target system configuration and enter the value. Basically, after that step, we are done with the configuration of the secondary feedback, and we can go over to configuration of our safety project. After the configuration of the secondary feedback from the alias device point of view, we can continue with the integration into our safety project. So in the first step, we are opening our connection input TwinSAFE group. There we have two variables, one variable for the acknowledgement of the module errors of channel B. So we add an additional mapping to that variable for the secondary feedback. And the second variable we need is the enable module signal. In order to turn on the secondary feedback, we also have to map it to the secondary feedback. Same as for the connection inputs for the error handling. When we open the error handling, we see a function block errors channel B, which is handling all the errors of the channel B modules. So we also have to handle the secondary feedback error. So we create a new variable by copying the old for the primary feedback and renaming it to secondary feedback. And we have to map that signal to the alias device target system to the error signal of the secondary feedback. So secondary feedback error. And we mapped it within the error handling. So now we have the integrated connection input handling and the error handling. So now we can go over to our desired safety functionality, to the safe limited position. When we open the safe limited position TwinSAFE group, we see the first function block SLP, which is per default configured for single turn and multi-turn positioning with the primary feedback. So in order to use it for the secondary feedback, we have to change the mapping of the signals. So we create a new variable by renaming the old variable. We rename it to secondary feedback safe single turn position. We don't need a multi-turn position because we only have a single turn encoder. So we also have to deactivate the multi-turn input. And for the safe position valid signal, we also rename it to a new variable name, position valid. And after that, we can delete the old 3 variables for the primary feedback in this group. And we have to map the variables for the secondary feedback, alias device target system, channel B. We have a safe single term position for the secondary feedback. And we also have to map the position valid signal to the corresponding input for the secondary feedback. So secondary feedback position valid signal. The function block itself is per default configured for multi-turn operation mode. So for our single turn, we have to switch over to single turn operation mode, and we enter the encoder mask, which is the maximum 32-bit integer value. We also enter it to the encoder submask and enter our scaling factors we pre-calculated for our encoder. And last but not least, to get the system running, we also enter the maximum 32-bit integer value as single turn position upper limit, so we can start testing the functionality. And after saving all, we are ready for the next step. Now that we have configured both the alias device for the secondary feedback and the SLP functionality, well, the basic SLP functionality, where we have now the upper limit, the 32-bit maximum value. We now want to determine the exact parameters. So first we download the current projects for the AX8000 by choosing the devices and entering username and password. So we start the download. After the download, we are verifying the CRCs and activating the safety projects. Because we did some changes to the process image, we have to activate the configuration. And after the system is up and running, we can go to our SLP TwinSAFE group and activate the online view, and also activating the option show online value in order to get the analog values for the safe single turn position. To have a better overview, we are also starting the drive manager and move it side to side to the safety editor and go to the Run Motor tab. If you look at the function block within the safety project, we see that the position valid is not here for the secondary feedback, so we still have to wait. And the basic idea now is to use the manual control of the drive manager to move the drive to the 2 position, to the minimum and maximum position we want to monitor with the safe limited position functionality. Now the position valid signal is here, and we can move the drive manually. So we drive in the first direction, and then we remember our analog value 17613.750. Then we can move to the other direction. After getting to the desired position, we also note our position 9638750. So we can now parameterize our safe limited position function block. We deactivate the drive manager and the safety editor online view, and then we enter our remembered parameters as single term position, upper limit and lower limit. And now our safe limited position functionality is ready. So we have to start the download again. This time we only need to download the AX8000 project. So we enter the username and the password for the AX8000 and start the download. We verify the CRC and activate the safety project. We don't have to activate the configuration again because we didn't change the process image. So now we are ready with our safe limited position functionality and continue with our testing. Though now that we have done all the configuration for the position and speed functionality, we want to test it, of course. So we go to the drive manager for channel B. We go to the tab run motor. Yes, we are sure. And then we are enabling the controller and resetting the error. And we start a reversing sequence from the position -100, the velocity of 10 millimeters per second. And we start the reverse sequence. Because it's within the speed limit, the axis moves as expected. But when we stop the movement and increase the velocity to 20 millimeters per second, we see that immediately our safe limited speed functionality is working. And for the safe limit position functionality, we do a manual movement of our axis, and we see that when reaching the position -159, well, circa, we see that we get a position error of the axis. So both the safe limited speed and the safe limited position functions are working as expected. That was all for today's live demonstration. Next week, we take a look at the retargeting of TwinSAFE Motion Wizard projects. So in default case, our TwinSAFE Motion Wizard creates a project for the AX8000 in communication with an EL6910. And next week, we describe how we can retarget that project to an EL1918, for example. Thank you very much for your attention. I hope we hear again in the next tutorial.